All right, let's go. Hello. Hello out there. Hi, everybody. Good morning, good afternoon, good evening. Thank you for tuning in today to our 49th episode of the Solace Office Hours. I am your host, Aaron from Solace. And yeah, we got a real special one for you today. I'm coming at you live from Malta in the middle of the Mediterranean. So it's kind of middle of the afternoon here. And yeah, today we're going to be talking about the Solace Agent Mesh, our AI agentic solution. And it's going to be presented by our very own, let's bring him on, Ed Funnekotter. Hello, Ed.
Hey, Aaron. How's it going?
Hey, welcome to the stream. Thank you for being here. I'm doing well. How are you?
Oh, great. Yeah, here I'm talking live from Ottawa, Canada. And,
Headquarters, yep.
Headquarters, yeah. And it's great to be back. I mean, I've been on office hours before, and it's always a fun time to show off what we're doing and have a conversation with you.
Now, the last time we did an office hours, it was you helping me present my demo, and I got the timing wrong, and we ran very late. It was an hour and 3/4. So I'm hoping that you're more prepared than I think I was. I kind of rambled on a little bit too much. So yeah, thanks for being here. Why don't you introduce yourself just a little bit so people know, for those who don't know, who you are.
Sure, yeah, thanks. So I'm Ed Funnekotter. I'm the Chief AI Officer here at Solace, whatever that exactly means. I really head up the AI team, and our team does both internal and external AI, which means that we're looking at how do we make our own company more efficient, as well as build AI into our tools, well, products, I should say. So, and mainly for our products, I'd say what we're focusing on is how do we elevate our venting platform, the Event Mesh, to use AI in a very real-time way? And how do we get agents to talk to each other in a very sort of decoupled and Solace event-driven architecture way?
Yeah.
And so that's really what my team does here at Solace.
So it's kind of a bit of both ways, right? It's like, how do we get our platform to use AI? How do we get AI to use an event-driven kind of architecture? So, yeah. So you're from Ottawa. I'm usually I'm often in a lot of different places. Yeah, I'm in Malta. But for all the people out there listening live, we are live on YouTube and on LinkedIn and at the Solace community. If you are listening and can hear us, put in the chat where you're joining us from and say hello. Give us a wave, and we'll give you a shout out. So, we actually have a few people already joining. Hey, Giri. Hello, Bangalore. Thank you for joining. How's it going? Hey, Marcus from Germany, Waldorf. Yes, welcome. Thank you for being here. And Mark, good morning, good afternoon from Orlando, Florida. Not Orlando, Australia, I'm guessing, or Orlando, Timbuktu. People are supposed to know where Orlando is, I guess. It's in America. So yes, more people out there, say hello. We have a random LinkedIn user. Sometimes your security profile is set up so that we don't see your name, but hello, LinkedIn user. Welcome to the stream. Glad to have you here. Okay, so Ed, what are we going to be presenting today? Some Solace Agent Mesh, I guess that's the name of the title of the show, right?
Yeah. So, I mean, a few things. I want to first go over really what agents are, what an agentic platform is. How do you build AI with agents, and what can it do for you? So we'll talk about that a little bit to start with, and then we'll get into how Solace sees a deployment of agents, work with our technology and make it really deployable and manageable, which I think is a bit of a struggle right now with actually trying to use this stuff live in production.
Right. Still growing, some of the growing pains, I guess. So fair enough. All right. So let's, I guess we're going to do some slides first, just to kind of set the stage. Before you do, a few more people shouting out. So I gotta throw them up here. Hello, Rachel from Virginia. Welcome to the stream. Navneet from Ottawa as well. Thank you for joining. Hello, Jerome from Utah. Excellent. LinkedIn user is back from Singapore. Hello, welcome from Singapore. Vikrant from Mumbai. Very good. And hello, TK. Hello, TK from Ohio. Excellent. Thanks all for tuning in. Yeah, if you have questions, if you have comments, we are here to answer them. Put them in the chat. I'll try to keep an eye on them. I have Mark backstage also keeping an eye on things. So Ed, we might interrupt you on occasion to to ask some questions. But yes, that's why we're here. So let's we're going to do this presentation. Please ask us questions, and there should be some live demos. Hopefully they go well. So let's share your screen here. I'm going to put that on now. And yeah, over to you, Ed.
All right. Yeah, thanks, Aaron. And let's keep this a conversation as much as possible. So definitely feel free to throw questions in, and I'll do my best to answer them. So like I said, I wanted to kind of start off just talking about the technology in general. And, 2025 really is the year, I'd say, of AI agents. I mean, talk about years. I think in AI these days, it's more like the month or even the week of different things. It changes so quickly these days. But starting off with what an agent is, and I think this has coalesced a little bit, over the last year or so. There's been a lot of different types of definitions for what an agent is, but I think it is kind of, narrowing down in my mind to it's a piece of software that utilizes a large language model, usually in a loop, typically to take in a goal or request and then use tools to fulfill that request. So, a request goes in saying, I don't know, I want to search a database for something or go to an API to retrieve some information. And the AI agent will take that, ask the LLM with some prompting and stuff to create a plan for that, and then give it the list of tools that it's capable of calling, and the LLM will create a plan. And generally, one or two or more tool calls, which will go and get information or process things or do some actions or something like that, and then take that result back, go back to the LLM and say, I got this result, what should we do next, essentially. And so it really is a kind of like a worker, usually domain specific, it's talking one or some related databases, and it will perform a task. So, very useful, very sort of, you can build on it and add more stuff to it to actually give AI the chance to kind of step outside of what its training is, because it's on real-time data and stuff like that.
So the agents would be more specific to a particular function or task rather than a jack of all trades, right? Like an individual agent's good at, or can you do both, I guess?
I mean, in general, I would say so. I mean, there are some conversations about just saying, all right, give it all the tools in the world, essentially, and have one agent just manage all that stuff. Okay. But my own feeling is, through using this type of technology, is that it works a bit better like a company does, or a business, where you have your boss who's in charge of understanding the capabilities of the company, and then you have your individual workers that have domain expertise, right, and are able to kind of dive in and get their job done, report back or produce content back to the boss, who can then take different results from different workers and put that together at a higher level.
Sure.
And I think part of the reason for that, like why I believe that it's better to split these into separate agents that have domain expertise, is that you do have to give them a lot of context and knowledge to do their job properly. So if you have one of them that's like an HR agent for your company to answer questions for internal employees and things like that, you want to be able to give it a lot of knowledge about how to get different policies, how to interact perhaps with some of the HR tools and that kind of stuff. And that takes context of its LLM input. So if you wanted to do that, as well as all these other aspects of your business, you're putting a lot of information into your input request to the LLM and say, sort through all of this stuff. And we know that agent or large language models do perform better when they have a bit more concise, focused sort of task in front of them, rather than just the world, right?
Okay, cool.
So again, like if you look at this example here, like a typical agent will have, again, this sort of loop it does with the LLM. On the left here, I have these different tools. And one, this little logo you might not be familiar with, this is MCP. So there's a protocol, a standardized protocol that was released by Anthropic like late last year, that was very good, and it's been really adopted quickly to make it easy to interface an AI model with some kind of tools or backend system or API for a SaaS service or something like that. And so as the software has grown in the last few months, there's a variety of different libraries and things you can use to very easily interact with those things.
Okay.
Or you can say, I want some sort of direct API call, perhaps. This is really just an example here, but it could be that you don't have an MCP server for it, but you just write a little bit of software or something to talk to an API. You might have local functions, again, depending on your framework or your libraries that you're using. It could be very easy just to create small little functions as part of your agent software to provide access to things, some kind of custom database you might have locally, or you want to interact with the Linux shell or something like that. You can do all of that through local functions pretty easily. And again, there's a lot of flexibility in how you call these things and how the results come back. So that makes sense, Aaron?
Yeah. So far, so good. Yeah, I guess APIs could be any kind of REST API that most people are used to, gRPC, kind of anything that just provides a request reply kind of semantic to
request reply,
whatever it is. Yeah. Okay.
Exactly. So what's the next step? I mean, like I said, I think, in my opinion, agents should be somewhat domain specific. So if you want to build a more elaborate system, a more fully capable system, you need to have more than one agent. And this is where things get a bit more complicated. You can imagine an agent's, it's software, it talks to LLMs, calls tools or whatever, and it kind of does its task and responds. So that feels like a natural kind of environment that's straightforward. But once you get a network or a group of agents, an agentic platform, now there's a harder, more complicated thing. I mean, there's a few different questions you have to answer. I mean, are you going to allow all agents to talk to all agents? Are you going to have a supervisory or orchestration layer that's going to actually, go and pick your different agents to talk to, and none of them talk to each other, but then your upper one kind of can talk to these ones. And depending on how you want to manage that, it does become a lot of extra overhead of how do you let them talk to each other? Where are they all running? Do they even have connectivity between them? How do they know about each other? What's the discovery mechanism? All these things are really a fairly large distributed application problem. And it's not an easy one to manage or solve, to be honest.
Sure. Things can come and go. The new capabilities can be added. How do you find where those are and what those are and all that kind of management level stuff, right? So
exactly, yeah. How do you manage the life cycle of these things? I mean, clearly they're all full of different libraries and things like that, which will have security vulnerabilities. You'll have to be updating these things quite frequently. On top of that, you want to upgrade your large language model as well. So you want your platform to be able to abstract that fairly well. Excuse me, so early here in Ottawa.
That's all right. Sorry about that.
Yeah. So, but this conversation is a tricky one, and so it does again create a lot of problems. And so, if I move on to a few different kind of things that you need to think about as you're building this. I mean, one of them, which I haven't even mentioned, is how do we talk to it? So you've built the platform, you have potentially multiple agents, they know about each other, can talk to each other, you've managed to solve that problem, which is not easy.
We've assumed that.
But but now you have to actually have inputs and outputs to make use of the system. And there's a variety of different use cases you might want to solve, and ideally your platform can do them all. So that's a whole other kind of issue with which agent do I talk to start with? How do I, if I want to do, say, a chat experience, how can I input requests and get responses back? How can I have an event-based system where something just happened and I want it to trigger the agentic platform to take care of it somehow? And even ones that are sort of semi-autonomous where you kick off a long-running type of operation. So it's not truly a chat experience. It's more like I ask it to do something and get it to come back to me later. Okay. There's other things about how do I get it to do human in the loop? How do I while it's running its work, how do I get it to ask or call out to people to just verify or approve certain things that are going on, just because AI is not foolproof right now. So that is a whole other thing that people have to think about and can be difficult. Security in this is clearly important, and it's quite challenging as well. All of these tools, if you have an API or MCP server or whatever, how do you manage token access and stuff like that so that if a person is talking to the system, they get their access control when you talk out to one of these third-party services?
Yeah.
That's not straightforward, clearly.
If it's talking to confidential databases, employee records, all sorts of things, right? You really need to make sure that these agents are only accessing the stuff that you the user, can see, I guess.
Exactly.
Yeah. Okay.
And then there's even which agents are you allowed to talk to? I mean, that's the next layer up.
There's layers.
You have to authenticate the user just to say you're allowed to even use this thing, let alone the backend service behind it. Then you also have data and data movement. And this is a tricky thing as well. Let's say you have one tool that's able to go access, I don't know, your HR records. You can get your salary and stuff back, whatever. You don't want other people to see that. But then you have another agent that's able to talk to Jira, that's able to create issues for you and stuff like that. You certainly don't want the AI platform to pull stuff from HR and put it into a bug report for some reason because it messed up, right?
Probably not, yeah.
It's like, you complain about your salary to the platform and it says, okay, well, I'm going to pull it out of HR and I'm going to create an issue to send it off to HR to say, this salary is not high enough for me.
Raise a bug for HR to increase
exactly.
Yeah. Maybe that's not such a bad idea.
Get the agents to do your negotiation for you. But again, it's a tricky thing, right? It's how do you manage this sort of data, security within there? And it is a problem as well. Like, I think MCP kind of came out and is largely used, I'd say, today to provide access to these backend services for something that you're running fairly locally, right? Like it might be your IDE that's plugging in these things, or you have a desktop kind of chat experience that's plugging those things in.
Yeah.
But what that means is that everyone's running these things themselves. They're the ones now in charge of the security, the possible crosstalk, the tokens. So where are you putting your tokens? How are you making sure that these servers are up to date and not malicious in some way? And it's a big security nightmare. And I think most enterprises, I'm sure, if they don't have them already, will have policies to say it's not advisable or really not allowed for you to just be creating these, AI-driven integrations with our backend services where you're going to those services, grabbing tokens, and then just jamming them in a file on your computer or your laptop and saying, yeah, go to it. It's a risk for sure that I think people want that integration so badly, and they don't have the platform available to them, so they're just doing it. But I think for proper security in the future, I think these enterprises are going to have to rein it in. So security clearly is tricky.
Not everybody thinks about security at the beginning. You're just trying to get things working. Especially if you're a developer, you're just trying to get it going. And security.
And I think, the magic of AI today is that it can really accelerate you, but having the relevant data and access to your tools is essential for that next step of I want to chat about this new feature I'm doing, and I wanted to create a whole bunch of stories for me in Jira. I don't want to have to cut and paste stuff or whatever. I wanted to just do it, right? So people are just sort of slamming in these MCP servers here and there and everywhere to do that, which is great from an efficiency point of view, but ideally your enterprise can manage that stuff for you. The last one I have here, how do we grow? So, you might have built this little system. We've got 3 agents here. They all know about each other, probably through some configuration to say, here's where this one is, and here's the address of this other guy or whatever. But over time, you want to add more stuff. You want to do it dynamically. You might want to do it in different areas, different clouds, some on-prem, whatever. You don't want to be constrained to have to be within the same VPC potentially. And that becomes an issue as well, especially since some of the protocols we have here to communicate between them require connections set up in both directions, which can always be a big pain in the butt when you have to set up firewalls and poke holes through different things to allow these guys to communicate. Yeah. So, this is all a big, tricky distributed application problem that fortunately is what literally Solace has been doing for 20 years.
And not just the heterogeneous kind of like layout of these things and where they're running, but also just the complexity of the number of connections that you have between different things, right? So if we remember our combinatorics from university, n choose 2, many connections, so like as you scale the number of objects, if they're all connected to everybody else, the number of connections grows quadratically, which is a lot to manage, right? When you have 3 things, that's pretty easy, but when you have 50 things, that's a lot of connections to monitor and to keep track of and to instrument and whatever, right? So
and you want to be creating each next one is that much more work, and like you say, so it becomes a real disincentive for adding new capabilities to the system. Yeah. So anyway, this is all sort of some problems, and I wrote some of them down here. I mean, it's kind of repeating some of them, I think, but the deployment and management of this system is tricky. Like building it, like I say, comparatively easy. Just experimenting with these frameworks and setting up an agent and that kind of thing feels, somewhat magical. It's not that difficult, but trying to run it in production is difficult. And, there's teams at large enterprises that do this all the time for other purposes. But there's a lot of new wrinkles associated with these types of platforms that need to be solved. And the other part of this is that it is not a static system by any means. I mean, most of these enterprise systems aren't really static, but this one I think is going to change more than most because of all the different capabilities that keep getting added almost on a weekly basis. Security, we went over a lot of different things there already. So it's, you really want, as an enterprise, to, I think, constrain the, who is allowed to run this stuff. Okay. Because again, you're really to make it useful, you're constantly reaching out to different services that you need to have token access with and all that kind of stuff. And if you want it to be secure and up to date and whatever, you need a team that's really in charge of that. Right. And the life cycle of the agents is tricky and important. Again, things are changing quickly, and there's going to be a lot of different libraries that need security updates and stuff like that. So you need an easy way to be able to just swap out agents, under the normal course of operation. And that can be, again, it's a tricky thing to do. Performance management, as hopefully the success of the platform rises and becomes more used, you need to measure where the bottlenecks are and be able to do something about it, like horizontally scale your agents or whatever. And that's also something that's, first, you need good monitoring to see where it's happening. And secondly, you need to have a platform that lets you do that.
Yeah, I was going to say, we have some experience from that internally. Some of the tooling that you and your team have built. Occasionally, once in a while, I see on Slack someone has a performance issue, and you guys have the tooling and the instrumentation to go and kind of dig into where in that chain of flow where things are slowing down or bottlenecking. And it's important because your users are going to want things quick. So performance management is pretty important too.
Yeah, absolutely. So it's very, very key. So anyway,
before you just launch into the next slide, I do want to throw up a couple hellos just because they've been sitting here for a minute. So give me a second, Ed. Take a drink of water. Good evening, Sumit from Singapore. Hello. Hello from Jersey City, Mr. or Mrs. LinkedIn user. Hello, welcome to the stream. Thank you for joining us. Keith, another beautiful day. Yes, it is. It's a Solace beautiful day. Wherever you're joining us from, thank you. Hello, Matuki-san. Hello, welcome to the stream. Thank you for joining us. Hey, Barris from Istanbul in Turkey. Good to see you. Ali, also at headquarters. Thank you for joining. Thanks for being here. And Running Roach. All right. Good to have you with us. Good evening to you in Hong Kong. All right, Ed, back. Let's do the next slide here.
Yeah, so let's get into Solace Agent Mesh. So we're trying to solve all of these problems that we've talked about. How do you deploy such a thing that can be managed effectively, can communicate with each other, can be grown over time, all of that type of stuff. And what we've done, I mean, again, I've mentioned Solace's background is in building large distributed applications using an event-driven architecture. We have our our event platform, and in the core of it, we have our event mesh, which is a mesh of brokers, event brokers that are capable of doing pub sub type of architecture, so that anything that needs to communicate with anything else, all it needs to do is connect into the mesh and subscribe to the topics that it needs to receive, and it's able to just publish the events or messages out into the event mesh, and it will get to where it needs to go.
Mm-hmm.
So that just simplifies so much stuff. The event mesh has a queuing architecture, so you can temporarily take down an agent or swap over to a new agent of the same type, and these queues will then just hold back a request
Guaranteed
very
messaging.
briefly.
Won't get lost.
Guaranteed messaging, and then it will just send it off to the next one. So you can very, very easily lifecycle manage. You can very easily horizontally scale, and you can really manage the connectivity extremely well as well, because all of these different components just need to reach out to this event mesh, which we can run as a service at Solace, or you can run yourself on-prem or in the cloud or wherever you want. And it's a extremely low latency, high throughput platform that can just simplify this deployment nightmare that will come.
And importantly, in terms of like connection scaling, it is just a single link between the agent and the mesh, right? To whichever broker is closest to it in the mesh. And that brokered communication architecture gives you that many-to-many style of communication. Any agent can talk to any other agent through the mesh, but it's not like I have to go and connect to all the agents at once. So you got to connect to the broker, and the broker deals with that thing. So very simplified in terms of your communication kind of connection pattern as well.
Yeah, exactly. And then another big benefit, of course, is that when these agents come online, they just need to connect to the mesh, and then they will just publish out their capabilities.
Right.
So essentially,
this is what I can do. Hey, I'm here.
Yeah.
Yeah.
Exactly. They have an agent card, which is basically a description of here are my abilities, my skills. Can I stream and all of that kind of stuff, and publishes it out into the event mesh to a well-known topic. And then everything else, all the other components, agents or gateways or whatever, can just subscribe to that topic, and it will be periodically refreshed with every single agent that's out there. And so it becomes very easy within the system to learn about everything else without having to have configured well-known addresses to go to, or another registry that you have to run or something like that. It's just a simple, easy thing to do in this type of architecture.
Mm-hmm.
So other things in there are, again, the communication between agents and stuff is easy because it just goes through this mesh. And the mesh can span, on-prem, in the cloud or whatever. It's just built that way.
Across different geos, everywhere. However you want.
Exactly.
Yeah.
So let me just talk, though, about the other components in the system. We've talked a lot about agents so far.
Sorry, Ed. Mark, I was going to save this for a bit later, but Mark flashed this up here. Ali asked a question. Can you expand on the value of data management? Do you want to do that now?
Well, I'm just going to go through the components. So yeah, no, I'll get to there. Just as I walk through these things.
Sure.
I just want to talk first about gateways, because I talked earlier about the maybe difficulty, or at least one of the things you have to solve was how do you interact with this group of agents, this agentic platform. And so we have a concept called gateways. It's just a different component that runs as an independent process that communicates over the event mesh to all these other things. And so it uses a similar kind of protocol, like you would talk between agents, but this one's more of a client side of it. And you could have a variety of different ways of communicating. You could have a user interactive one, like for Slack, or a web-based one or whatever, and that will give you a chat experience. So we push the request in, it does a whole bunch of stuff and gets a result out. But it could also be a whole bunch of different other ways of getting requests in, like event-based ones. And those events could be coming from the event mesh itself. You might have other systems that are running stuff over Solace, or other brokers, frankly. And you might subscribe to that as an input into the system, and you have a template there to say, here's what you should do when you receive this event. Or we have a gateway that's like, it's a webhook gateway. So basically you just post to an address with some data in a HTTP message, and that will just go in and then be processed. And so it's very, very easy to integrate other systems to make use of this system. Moving on, the orchestrator, this really is kind of like another agent essentially, but it's in charge of a higher level. So it fully understands what all the different agents are, what their capabilities are. And so a lot of requests, I mean, you can bypass it potentially and go straight to another agent for a request, but a lot of requests, especially the user interactive ones, will go there and say, this is what I want to do. And its job is really to figure out how to solve this request across the landscape of agents. And so it doesn't have to worry about the nuts and bolts of calling different APIs or, interacting with some MCP server. It just has to understand, oh, there's an agent over there that interacts with Jira, and you want to do some Jira stuff? Great, I'll just sort of forward that request over there. And that's fine. And, if it was just Jira, maybe you could have gone straight to Jira, but you might have said, I want to get all of my bugs that are open right now with Jira, but I also want to get this other data from our support database or something like that and do something with the two of them. And so the orchestrator allows that kind of behavior in the system.
So it can decompose a more complex problem into smaller subtasks, and then I guess it restitches things back together afterwards? Or?
Yeah, entirely. Yeah. So it's, it might create a report from 3 different agents' outputs and merge them all together and analyze them together. And this is really essential because you don't want to, if you were, as a person, were interacting with these different agents and you got back great results from the 3 of them, but your boss wanted a report that had data from all 3 of them, you don't want to be the chump that has to put it all together yourself. You want AI to do it. So clearly you need something, a hierarchy of agents inside here.
Got it.
So data management.
Data management,
We're getting there. So data management is pretty key, and it's another problem I didn't really touch on earlier when I was talking about agents, but it becomes very obvious once you start trying to use these platforms with proper kind of use cases. And really, when you have agents, then more so you have the tools on the other side of these agents, they will produce data. You might do a search, like I said, into Jira to get your bugs, and maybe someone just assigned you 1,000 bugs. Your result from that search may be very large. And if your platform is built to basically take any tool call result and put it straight back into the large language model and say, here's your result, go process it. Number one, it might be too big for it.
You can blow things up.
Blow its context.
Yeah.
But it also gets stuck in its history too. If you have a session that's going to run for multiple turns, every single time it's processing all of that data. Not only that, but you are relying on that AI model, this large language model, for the truth of that response. And so if for you to get it as a user, it has to go through a large language model and be regurgitated essentially on the other side to push it back to you, what's the chance that it makes a mistake? I mean, there certainly is a chance that we'll make a mistake. And if you have to rely on that, then I mean, good luck. Secondly, of course, you're paying per token, and you're paying time per token as well. And you don't want to shove big results through a large language model if you can avoid it. So the data management's an intelligent platform to look at what's coming back from tools or agents and all of that, decide what should be stored as artifacts, decide how to look at that data and describe it and reference it, so that instead of giving the large language model this huge result, it gives it a very intelligent sort of view of what that data is.
It's like a summary, like if in layman's term, kind of, or
basically it depends on the type of file or data. Like if it's a JSON object, it might go and discover the schema and tell it the shape, like how many entries it has and that kind of thing. Or if it's a CSV file, it would give you the headers and the number of rows, maybe even the first few rows, so you can see some example data. So then you kind of understand. I mean, you can imagine as a person, that's what you would want, right? If you were asking people for a bunch of stuff and you had to take that back and do something with it, you wouldn't want to start with like pages of data. You just want to understand that I know how to get it, and I know what it looks like. I don't need to know the data itself. And so this is what data management is trying to do. And it surrounds the LLM with a lot of other kind of abilities to consume that data in a more reasonable way. So you can go and dive into, just give me that sub-object of that JSON that came back. I don't need to see it all. Or, create a template so that it can, process that in a different way that's more software-based, not, AI-based.
And these are all components of the Solace Agent Mesh that we have available for people to try.
Yes.
Right.
Exactly.
Okay.
Yeah. So,
by the way, I guess I should mention that while people are listening to this and wondering like what we're talking about, and is it some abstract thing? No, it is not. It is available for you to try. And that's one of the things we're doing this presentation here with Ed, is to talk about it. It is available on our GitHub, right, Ed? You guys have released it where I got a special marker here. Yeah, it is available on our GitHub repo. We got 2 tickers going at the same time. Thanks, Mark. Head over to GitHub, Solace Labs/Solace Agent Mesh. Take a look at the repo. You can try it out yourself. I'm sure Ed's going to kind of walk us through a couple things. You can scan that QR code up in the top right over there. Yeah, rather than just listening to us talk about it, why don't you check it out and give it a try yourself? But you are going to see Ed doing a live demo. Well, hopefully a live demo in just a few minutes. But I do want to say that this is not vaporware. This is not slideware. This is something that you can go and download and try for yourself. So be sure to head over there, check it out, star the repo, and to help drive some interest and visibility for our platform there. So yeah. Sorry, Ed, back to you. I just want to get that in there.
Yeah, I'll just touch on a couple more things on this diagram before we move on.
Sure.
I've got visualizer over here on the side. So
right, what is
clearly,
that? Yeah.
If you're building one of these systems, or even just using it later on, or debugging it, or supporting it, you need extremely good visibility into what's going on. You clearly also need security with that, so it's important that you can manage who can see what in a fairly fine-grained way. But during development, especially, you want to be able to see for a single request that comes in, how does it go? Which agents does it go to? Do they behave the way you expect? What data is produced? Can I look at that data? All of that stuff is very important. And that's what this visualizer component does.
Yep.
AI service, this is really an abstraction between how agents use AI in general, large language models often, but there's other types of models they could use. And how do you not kind of hard code model names into these agents? Rather say, in our system, you'd say, I want to use the planning model, or the fast model, or the coding model, or whatever. And we have a mapping that allows you to change which models actually service those independently of where the agents are. So it's just a nice abstraction, so you don't have to worry about taking down 50 agents to fix which model they're going to. It just happens within the system.
Okay.
So that's sort of Agent Mesh. Let's see, time. We've got about 20 minutes. Basically, I've gone through these things already. I will just quickly point out the bottom here. Because this is a completely decoupled system where each one of these components is independent of each other, but they can communicate in a very easy way, it really gives you this very flexible system. It's composable over time. You can add gateways, you can add agents, you can add more AI services and change them on the fly. These things, it's sort of, again, like as a Solace employee for a long time, it feels very natural to have that as a capability. And I don't, most of these agentic platforms don't really have that much freedom to just add and remove things, on a moment's notice. And I'll show a little bit of that in the demo afterwards. But, that's clearly a very important thing.
We've definitely come at this from the kind of like the background of event-driven kind of distributed systems, like first, right? Kind of how we approached the whole event mesh as a networking kind of thing rather than application integration space. So yeah, it's a different way of thinking about these things.
No, absolutely. And if you look at the background of Solace, and I've been at Solace for over 20 years, we started out in the financial industry building hardware for high rate, low latency trading systems in some of the biggest banks around the world. And so we know that side. right? We know how to build these robust platforms that can communicate and move data. So it is needed so badly in this space, and it's such a a nice synergy that we can have a platform that's robust and capable of this, and then couple it with this growing agentic and AI space. It feels good to me for sure. I just say reuse your AI platform. I mean, this is where you can control. There's various knobs and things and ways of scoping things to, have an individual or a gateway only get access to certain aspects of what the platform is. So it's important to really not have to create, 50 different platforms. You can create one or two, or depends on your enterprise how many you might make, but you don't have to have a brand new one for every single use case. There's various security stuff, streamline costs. This data management thing again really can cut down on how much data you shove through models, and that can really both make it go faster and make it be cheaper.
Save some money.
Not to mention it doesn't make mistakes because the data is not necessarily being regurgitated by the AI model. So I will step through this
before the use case starts. We have a couple questions there. Just want to
sure.
We can say if we want to do it right now or in a second. Just a few hellos. Hey, Ramesh from Chicago, Phil from London, welcome, and Jamil from London. We already talked about that. Jesse from Boston. Hey, Jesse. So here's your question, Ed. In a similar theme to human in the loop, would this architecture help with the circuit breaker type requirements where you can quickly pull the plug on an AI platform if a certain thresholds conditions get met to mean the AI has gone awry? I guess if your AI is calling out to you or to some other thing to kind of verify its work as it progresses through the stages?
Yeah, I mean, clearly any of these components could be shut down very quickly. And with having a central platform in the middle, you could certainly shut down aspects of it there. You could have a monitor that's actually monitoring, all the different communication paths between these things, and you can shut down a queue. You can, examine a queue, and like I said, you can subscribe in a fine-grained way to what's going on. So not only does it provide you that access and ability to circuit break, but I think it even more so provides you the access of auditing and monitoring things in real time to see if you need to do that.
Publish, subscribe. Yep. I want to listen to parts of this stream, just listen to the topics and see what's going on.
I mean, again, it's like in this diagram, like you've got this event mesh in the middle, and like a lot of the value of a pub sub architecture isn't necessarily the first instantiation of it, where you've created these paths of data flowing. It's the next application.
It's the next N. Yeah, exactly. Yeah.
And it's the meta applications where you're actually doing something that's at an even higher level. That's not so much looking always at the data itself, but the movement of data and what can you divine from that. So there's so many more things you can do once you set up the platform to use it afterwards.
That's one of the things I love to preach during developer workshops is, it's the future extensibility of the system, right? It's hard and, expensive maybe to get like that first flow on there, my one publisher and the one subscriber. But then if I want to come along and add another subscriber to do analytics or management or auditing or whatever, it just subscribes to that data and I don't have to change any of the configuration of the other components. Everything just keeps working, and application number 2, 3, 4 just subscribe to the data they want. It's kind of for free. It's very cheap, at least compared to the first creation. So yeah, that's a really good point to make.
Yeah. So, running out of time, I'm just going to switch over to a live chat session I have here. And I will mention this is a little bit in advance of release we'll go to open source. So an open source version that's out there right now doesn't have some of these features. And we're rebuilding a lot of the underlying sort of protocols and speed at which the AI agents run. So it's a preview, let's say, of what's to come. And it, again, it's quite interesting. I'm really liking this next version. So what I have here set up is an instantiation of the agent mesh. I have, if I look over here, a bunch of different agents in the system. I've got ABC Coffee, which was on that last slide, is a set of databases of fictional data for the coffee company. Markdown agent, this can convert documents. Mermaid can create diagrams. This is the orchestrator agents. This is the top level one that we'll communicate with, a report generation one, and a web one. So you can just add these things again on the fly. You can see their details here, all the stuff they can do.
Ooh, is that the card you were mentioning before?
So this is the agent card. Yeah, it's exactly.
Okay.
So this is what gets published by each one of these agents, and this application is just able to receive it. Again, anything that has the permission to can receive these things within the agent mesh. We've got a task monitor here. This can actually show the background, what's going on behind the scenes, and this is the chat interface. And within this, I'm able to actually choose which agent I talk directly to, but I want to talk to the orchestrator. And so this, just make sure it's up and running. Right now, I've set it up to use Gemini 2.5 Pro as my planning and sort of top-level agent or top-level large language model. I will mention that it's in high demand now in the world. And every once in a while, you'll see a delay here that's just, me waiting in a queue to get access to the model. But hopefully it'll be quick for this.
But you could use other LLMs if you wanted to, right? It's
yeah. You can use GPT 4.0 or 03 if you want, or 4.1. You can use often we have Claude Sonnet. It's a very good one as well. In fact, I have this instantiated right now with different models being used. I have the planning one, it's the Gemini 2.5, but the report generation one's Claude Sonnet 3.7 because it actually does a much better job creating documents. So, for all these different purposes, you can have different models, and you just get the best of breed across them.
Okay.
So, I'm just going to do a quick cut and paste here to, how did I get out of here? So I'm just going to ask for, in fact, I think I already have just a quick thing just to let us play with some data. So I just said, let's play with some data. Please create a CSV file with 50 rows of sales related data. You can make it up, put it into Sales 2. And this sort of an example of just show you of managing this data kind of behind the scenes.
Okay.
And I think I already have one I just ran before we started. And so it created some new stuff. Sales 1 is here. And, I've blown this up a little bit, so it's a little bit tight real estate right now. But you can see in the system all of the different data that's there that AI can play with. And you can manage this, you can delete it and add more, you can drag and drop into there.
Okay.
And at the same time, we can, again, look at exactly what's in here. This is a CSV file that it created with different products, different categories, how much, it costs and stuff like that. And I'll just show a couple of things of how you can, let's close that, how you can do stuff with it, right? I mean, I might say, let's see, get the sales amounts per category. So again, this is the beauty of just Agentic AI, is that it has this data in its hands, essentially, and it can use its tools to go and do different things. And it will literally use a tool to do a SQL search across here and create another, if I show here, another CSV file that's now actually summed up those values against the categories. And what's really important here is it didn't do this in its own brain. Like in many of the systems, it will actually read this thing in and add it up. And sometimes it's okay, but likely it's not going to actually be correct. And in this case, it's not adding it up itself. It's just calling tools to take a CSV file and run it across and do this. And then, it can do stuff like create a bar graph.
Where are you pulling this sales data from? Like, I mean, you have some database here. That's the.
So this was just, right? This was a very quick example where I just asked it to create some.
Yeah.
But okay. I do. So one of our agents is this ABC Coffee company thing, and I can interact with that agent. So anyway, so able to create a document here. And what's nice is it's always put into your artifacts, so you can click on here to get it after the fact. But so now I could say, like, what is or what ABC databases can you access? So just to kind of understand what we're playing with here. And so, customer products and orders, that's great. So maybe just say, give me a list of all of our customers. And so what I'm doing here really is on the fly data analytics, real-time data analytics, real-time dashboarding, dynamic dashboarding, lots of different names for this. But what it lets me do is play or chat with all the data I have at my fingertips. And so there's a bunch of SQL databases that are being served by this agent I have here, ABC Coffee agent. And the system is going and asking for different things. And again, in this case, it created this result here that is all the different coffee companies. And it happened to give the customer ID and the address, or not coffee companies, but all of our customers of this coffee company.
Yeah.
And so great. That's nice. But I can also say, give me the sales per customer for 2024, something like that, And, it has to do a very different kind of query now to get that data, but it will go and do that. It's going to figure out, the customer IDs, and it's going to do some sort of sum. It's all SQL based behind the scenes.
Yeah.
And, let's retrieve this information, which, great. I'll put it out here.
I've certainly noticed that some AIs make simple math mistakes, when trying to do summaries or averages and things like that. So, so it's not actually, it's doing this via SQL then.
Yeah, like exactly. So what we're trying to do is prevent it from ever having to do math.
Right.
From if it needs
probably good.
If it needs to generate a report, it's not going to again output all of these numbers in HTML or whatever. So this is the trouble with live demos.
Live demos. Yep. There we go.
So
there has to be one thing go wrong.
Yeah. Well, this is accessing the Gemini model. So every once in a while, I've got someone walking in here to give me something. Thank you. But I'll just run this again because this is not our system. This is the access to the backend model
of some sort. Yeah.
But
I'm sure you could get timeouts and other things like that once in a while as well, right? So that's
yeah. So again, here this is a much more consumable output here, which is now in a file. Mm-hmm. And shows us the sum of all of this stuff. And again, it's not being done by a model. And the other thing I wanted to say is, when you wanted to produce a report, these systems will often say, okay, I'll suck the data in, and now I'll spit out all of the HTML table keys or like the TRs and TDs and the numbers in between it all, whereas this system will just do it with the raw data and not have the LLM be in charge of actually creating that table.
Right.
But in a very flexible way. So it's not restricted to just tables. You can do it in Markdown or whatever. But, it's just capable of that. So all of these things are just trying to make the output as correct as possible. So you can see the raw data that the system has created, coming straight from the database, not coming from the large language model deciding what to give you. And you can get it to operate on this stuff without actually ingesting it. So lots of great things within here. I'm super excited to get this next version out because it gives you such more access to the stuff behind the scenes.
When is the next version due out there? I probably should have asked you that earlier, but
the plan is mid June. So
mid-June, very soon.
Yeah.
All right.
Yeah.
But people can try this now, right? So this is so what we have up now is, it's good, but it's next level version with all this kind of like protocol stuff coming in a month or so.
Yeah, exactly. And it's going to be next level, and it's the one that's out there today is great. It does all kinds of stuff. Mm-hmm. It's not as fast as I would like it. It's not. So we've really spent a lot of time to refactor a lot of different aspects to really, again, hone in on correctness of data and performance, like the two things that I think our first version, it was pretty good at correctness. Just as good as all the other systems, but this is really, again, the next level. And, super excited to get this out there because I really think it's going to change a lot of, how people do things.
One thing I guess we didn't get the time to show is just sometimes the dynamic nature of this stuff, kind of like streaming data in and being able to kind of build knowledge and stuff on that kind of stuff.
Yeah, we're going to have another one, another office hour.
Yep.
But one thing I did want to just quickly show, if we can, is, here we have a bunch of agents. I don't have an image generation agent. I would like one. So let's just run one, right? So here I'm just starting up another agent. It's already connected to Solace, that fast. And I can't remember if this page.
In order for this agent to work, like say you find something online, you're like, I want to build this into my agentic mesh. Like what do you need to build for it to talk over SAM, Solace Agent Mesh?
So I guess it depends on what you want to do in an agent, of course. This is very much low to no code. If you're trying to create a new agent that's, say, using a bunch of MCP servers or calling an API or something like that, that's you can use a generic sort of agent framework that we have. It would literally be just config that you would use to start a new agent. If you had some very weird internal thing that no one's built an MCP server for, or is not just a nice REST API call away, you might have to write a little bit of code. But writing that code still is literally just writing Python functions, and it will auto detect the signature of the Python function, all of that kind of stuff. So again, it's very, very easy to create these agents. And it's also, and I should mention, I mean, we're very compatible with A2A and MCP. So A2A is Google's agent-to-agent protocol. Very easy to bring one of those into the systems as well. Like we don't want to be the monopoly on agent.
A2A being to agent, I assume.
Agent to agent, it's the protocol Google just released about a month ago.
Yep, brand new stuff.
And it's, again, like it is a great thing because it's brought another standard to the system or to the industry, so that we can easily integrate agents into a platform because they have some kind of standard. It's not different for every different type of framework or whatever.
Sure.
So anyway, I just started this image generation agent. Didn't take the system down. I just started another one up, and now I couldn't before, but now I can say, get me an image. What do you want?
I don't know. You made a chart before, but I assume I think we're going to go a little bit more interesting.
Mouse in a house. Oops.
Oh, wow.
See if I can deal with it.
Correct your typo. Yeah.
And
I was going to say,
yeah. Okay, go ahead.
No, I was just going to say, I was going to suggest like a beach or something since I'm out here in the.
Well, you can look out the window.
I got a balcony across the way there. I have to walk down the street a bit. So let's see. So you just added this in. We didn't restart anything. We didn't say refresh. It just basically, there's your mouse.
Yeah, just started it up, and now the system's capable of creating a nice image. So, and it should be in here, so I can click on here and get it later. So anyway, I mean, it's just that dynamic, right?
That's
if cool. I wanted, I have another gateway. I could, we're probably out of time now, but I could start up the Slack gateway and then switch over to Slack and do all of this stuff through Slack rather than a web browser.
Right, rather than using the web browser chat interface, you could do it that way. Okay.
Yeah, and you have it's the same platform, so I can communicate. So if I want to use Slack on my phone because it's just there and it's easy, I could do that. But then maybe I want a richer experience when I'm at my desk, so I'd use the web browser.
I'm trying to think from like a business, like when would you want agents starting up and shutting down, like kind of dynamic, like maybe there's some service that's only available 9 to 5, and you can it's like, it kind of comes online and you can query it and then it goes away during off hours or something.
I'm not sure if there might be use cases for it to on a daily basis start and stop. It's more that you want to add them as you go, I think.
Sure.
So
you
have a platform that's up and running, but now it's like, we can now integrate HR with it, or we've done enough work and now we're integrating our support, back-end infrastructure with it. So it's that kind of add over time, and then maybe you're retiring things over time because either you've superseded it with something better, or it just wasn't really what you wanted. So let's get rid of that one. Who knows? But what it means is you don't have to, basically stop the system, change some config, start it up again. Yeah. It's just these things are just independent, and they have their own scoping rules for, permissioning and security and all of that kind of stuff.
Like
so you can
management.
control when it comes up. Only some people in your enterprise can see it. So it's not like everyone will get it necessarily.
Yeah. That is awesome. We do have a couple questions/comments here from the chat. I'm going to just throw up Jamil's here. I'm not reading these in advance, people, so hopefully they're good. Jamil, to better handle the lag from LLMs, can the agent mesh work with multiple in a competing manner? Like, I guess, fire off a bunch and see who answers first?
Yeah, so I mean, there's a few different ways of doing this. Like we actually internally use LiteLLM as our proxy for AI, and inside there we can configure multiple models. And if one times out, it will go like it'll actually load balance across them and measure their kind of rates that they get, and give you better access if you have the same or a group of models in different places. So the agent mesh itself is not doing that. However, we could. But I think a lot of different enterprises these days have their own solution for managing the sort of access to these models with a similar thing like LiteLLM. Excuse me.
Sorry, Ed, making you talk too much.
Yeah, a lot of speaking for an hour. Any other questions?
Yeah, there's one, a really good one from Samit, which I guess is kind of the fundamental aspect of this whole thing. How do you decide which agent needs to be invoked? I guess that's the orchestrator's job, right?
Yeah.
So how does the orchestrator know?
Well, it uses large language models. So you can say, like I'll just ask, what agents can you access? And so it will basically say, okay, these are the ones. And how it knows is, again, these agents have an agent card that gets published into the system. And this is what it sees. So part of its prompt that goes into the large language model will describe each one of these things and give it, say, okay, this is an agent that generates images from text, pretty straightforward. And it has a skill which generates a PNG image from a textual description. Yeah. And
so the orchestrator knows these guys, he knows really what they can each do. So yeah. That's cool. All right. A kind of a messaging related question from Giri here. Since events contain valuable metadata beyond the business payload, the messages such as generation time, I guess the send time, validity window, maybe the expiration, the publisher ID, source identity, does Solace Agent Mesh use any message metadata in any way to enhance contextual accuracy or event processing?
So if you're talking about like an event happens in the world and it gets directed to here to then process it, the way that works is that there's a gateway that has a subscription that can talk to a broker, and we'll assume Solace in this case. And when that event arrives, there's a fairly rich templating system that's available that can pull data from the input event. So it can go into user properties or within the payload itself. It can say, oh, this payload's JSON, and it can parse it and pull out different fields. And then within a paragraph of text or multiple paragraphs, you can put those values in there. So you can, as part of your input into the system, pull all of that different contextual information to say, this was when it was created, this is where it came from, and all of that. And then allow the system to make use of that. And you might say in your template, if this is more than a day old, do not service it. And you could have that. That would rely on the AI to actually make that choice. But sometimes, like, you really do want the AI to make some of those choices because it's not a cut and dried rule. It might require some permutation of many different fields, and the kind of solution space for that is so huge that you do want AI to make a logical deduction based on those values. So I mean, that's how I would do it in the system as it is today. You could have, the gateway today doesn't have it, but rules just to say discard this message if there's if it's out of whack somehow, and that wouldn't be hard to add, but it's not there today.
And obviously the fact that like Sam uses Solace messaging as an underpinning kind of communication paradigm, it doesn't. I mean, you might be using some of these fields or might not be, depending on how it's just coded up. So I guess we're talking more about ingesting, kind of external event data from somewhere.
Yeah, I mean, there's a lot of stuff we do use as the agents communicate with each other, of course. With ACLs and queuing and more sophisticated queue features, like all the stuff that Solace brokers have, which is a large quantity of features we can bring to bear within this environment to make it more robust and more recoverable. If you have failures in your agents and it fails, dies, and then gets either restarted, or you have an active standby, or just a standby there that would just immediately take activity and receive that request again.
Yep.
Which hopefully isn't poison or whatever. But even if it was a poison request that takes it down,
we
then
have
the queue
for
has
that
a max redelivery. So it's like, okay, it tries twice and then gives up on it. Which is a very important key thing, that you might have a bug that's, whether it's in your agent or in the requester, that somehow is causing a crash. Well, you don't want that thing to live forever and crash it forever after that.
All the features we've built for handling this kind of stuff, I mean, it certainly applies to AI, because they're applications too, right? So all that kind of special handling, it's good to do it on a platform that has it, like Solace, for example.
Exactly.
One last question here, Ed, from our friend Running Roach in Hong Kong. Will all components be open source available, or are there some components that will be restricted to purchase only?
Yeah, it's a very good question. I mean, clearly we're a business. So open source is pretty full featured, but some aspects of security aren't there. So, you want single sign-on and proper OAuth and all that kind of stuff. That is just not in the open source. And some of the scoping features that, again, security related or access control related, are in the enterprise version. There's some aspects as well of the data management that we have not put in the community, because we do think that really is a fairly substantial value that we just think is worth paying for. And frankly, I mean, if you're going to use this as a proper enterprise system, you want to pay for the support anyway, so that if things go wrong, you get quick and attentive support for it.
Awesome. Thanks, Ed. So besides the GitHub repo that we're hoping people go and check out, scan that QR code up there, give it a star, download it. Are there other pages on like our homepage that talk about Agent Mesh, or the coming soon?
Yeah, for sure. In our Solace product page, we have a lot of information there now. There's lots of documentation at the GitHub repo that you can read about how it works. And definitely join the Solace community, and you can ask questions and communicate with people there. You can raise issues, questions on the GitHub repo as well. So lots of different ways to communicate with us and see more about it.
That's right. And of course, because we do have the Solace community and we use it for a lot of notifications and kind of things, announcements. If you are a member of the Solace community, free to sign up. You will be up to date on all the latest and greatest coming out from the Solace Agent Mesh as they are released. So one last thing I'll mention, if you are not on our YouTube channel, youtube.com/@solace.com. Just today, just like 20 minutes ago, Tamimi dropped the first of his Solace Agent Mesh tidbit videos. There's going to be one coming out every day for the next week. And then there's a few more deep dives starting next week. These are brand new. The first one just got released just a few minutes ago. So you should be able to head over there, check the playlist, and look for Solace Agent Mesh to hear, a shorter version of this maybe. I think these are like 2-minute videos. So check that out, our YouTube channel, and subscribe. Help us get to 5,000 subscribers. We're getting pretty close there. Ed, we're a little bit over, but I think it was worth it. We covered a lot of stuff. Was there anything you didn't cover that you're definitely we're going to have to come back later when things are more version 2'd?
Yeah, I think so. I mean, it would be great after we've fully released to have another session of this. But like you said, the stuff that we haven't really covered is how do you use agents just within Solace itself, like not necessarily part of the whole agent mesh, because these things you could use sort of as micro integrations. And there's, some other just talking about real-time data in general, because we're talking about the usage side, right? How do you get an agent to go and access data that's there and do stuff with it? But the other side of that is how do you build up data stores in real time and have them be, up to the second accurate, so that when you are asking these questions, you're getting, real-time data.
Yeah.
So that's clearly a side of things that we play in as well, and we would like to talk about.
And a lot of our customers, that's what that's what they're using us for. They're not using us for old stale data or like they want real time data, and how to integrate these systems to make use of that is going to be important. Well, I'm pretty sure next month, if I remember correctly, we're going to have an event portal update with our colleague Daryl. He's going to be showing us all the latest and greatest event portal features. I believe, speaking of micro integrations, I'm going to have Andrew, I think the month after that, to do a big micro integrations update. So Ed, we might have to have you back maybe towards the end of the summer, maybe September. I don't know. It'll be in a couple months. We'll definitely have to do this again. Thank you for joining. Thank you to all of you out there for tuning in and listening, for checking us out on YouTube or LinkedIn replay. Head over to Solace Community if you want to ask us questions. People like myself, Mark, Tamimi, Giri, Ed, a lot of Solace R&D folk hang out on Solace Community where you can ask us questions, and we'll get back to you. Ed, any last closing remarks before we close off here?
I mean, just it's a pretty exciting time to be alive. This technology is insanity, really, and stuff we couldn't imagine a few years ago.
Yeah.
And, but to take the best advantage of it, you really need to bring your data to it so that it's not literally just, using its training to do stuff for you. It's actually answering questions on your data and using your systems to help accelerate you.
Yeah. So go get it, try it to yourself. You'll be amazed at what you can do. I'm continually impressed, and I want to try out this new stuff. So thank you, Ed. Thank you to all for joining. We'll see you in a month. All right. Bye-bye.